For those of you who are joining us for the third time in our series of 3 presentations, massive thank you. For those of you who are joining us for the first time, maybe hello and welcome, and I hope you get something from today and maybe take a chance to look back at what we have been talking about in this, as I say, the third of our 3 sessions that we've been running as part of our Cloud Networking Academy. Before we get into that and do a little bit of a recap, we will try and get through an introduction as quickly as possible. Always seems funny, keep doing this every time, but the challenge is to see if we can make it that little bit more succinct. So my name is Justin Day. I am the CEO and co-founder of Cloud Gateway. I come from a network and technical background, something of which I have been off the keys for many years now. I worked for Cable and Wireless, which later became and was purchased by Vodafone. Spent roughly half my life working in the private sector and half my life working in the public sector. It was in the public sector back in 2016 at the Ministry of Justice that I met Steve McConnell.
Hi everyone, I'm Steve McConnell, CTO of Cloud Gateway. I'm at least 4 times more technical than Justin. I started my career about 12 to 13 years ago, worked for a large gambling organisation on a big e-commerce platform. I've worked for a couple of financial services organisations and spent my time deploying call centre infrastructure. After that, I met Justin at the Ministry of Justice on the programme we're working on, and then I've been moved to Cloud Gateway ever since.
So I told you that we are in the third of our 3 sessions. Now is a good time to do a little bit of a recap. We built the 3 sessions on what seemed to make logical sense, almost chronologically, and how you may go through your network and cloud IT approach. So the first session, we talked about cloud fundamentals. So I think one of the things that we were talking about very specifically was the question, or the answer to the question, potentially, what is cloud? It's one that I unashamedly and unapologetically give a philosophical answer to. The reason for that is that I think that is really, for me, and I think certainly for business leaders that I speak to, probably what they talk about when we talk about cloud. So a quick recap on that was, I think if you go to the original tenets of cloud, certainly around scalability and flexibility, and the way in which you pay for cloud services, that's where an expectation was built. But I think expectation is the word. So when we talk about cloud, we're talking about consumer expectation. How am I expecting to consume the product or service? Really, we're talking about as quickly and efficiently as possible, as cost effectively as possible, and that things change as quickly as possible. So that concept of cloud is more an approach to me and can be overlaid into many things and in many ways. For the benefit of the sessions we are running, we are talking about Amazon Web Services and Microsoft Azure. We are talking about the public cloud. We are talking about the fundamentals of, the design of, and coming into today's session, which we'll talk a little bit about as well. So that was session 1. They were fundamentals. We are now looking at session 2. Quick recap, we were talking about design. So design in cloud and also outside of cloud. We talked about how public cloud really was almost like a data center, and therefore you were designing the concept of your architecture, whatever it may be, inside of that data center. But we wanted to talk about networking. Of course, that's why we're here. So we talked about looking at what is outside of the cloud before we talk about what was inside of the cloud. We had to understand the fundamentals, and it's very difficult to keep avoiding using that word, fundamentals of design in this case, of very traditional networking that you will continue to see today and will be part of the businesses that you operate within. So understanding how a WAN fits together. How do I connect my sites? Do I use a private WAN? Something that a lot of you may refer to as an MPLS. MPLS is actually the technology. How do I connect to the public internet? How do I receive traffic and the sessions and other bits and wonderful pieces from the public internet? How do I use traditional data centers? How do I get that working? We talked about how we might bring that all together. And then we looked at what was inside of the public cloud as well. Design concepts that become different because of the way the public cloud is put together. And that leads us to today, our third and final session, which is about deployment and troubleshooting. So there's very naturally a crossover between deployment and design. So we'll try not to fall into just extending the conversation on design. We're talking about deployment, how you may deploy, what that looks like. And then ultimately, we want to go into talking about some troubleshooting, some things that we've come up against, some discussions that we've had during the week. And if you would like to make this session interactive and you have anything that you have come across that is an issue, maybe something that you already know the answer to, so you're interested to see our approach to how we may solve it or resolve it, or an issue that you have that is live, we'd be more than happy to talk about that as well. Just a nice little segue into saying, thank you for those who have made these sessions interactive. That is what these sessions are all about. If you do have those questions, please do put them in. We've had feedback during the week. One of the most important pieces of feedback we had was that I made a massive step forward by taking the super dry t-shirt off and replacing it with a jumper, sadly one that Moira had seen before, so I've treated myself to a new one. But that's not the most important thing. We need to now start talking about the deployment part of today. So what we wanted to do was talk about the old world. And when I say we, you may have noticed that only I do the talking, and something else I'm not very good at rescinding. So I think now's a really good chance for me to actually pass this over to Steve. So when we talk about the old world, which sounds very almost prehistoric, we're talking about a world before cloud. So we're talking about the world that we came from when we started in networking and what that looked like. And there's a very different approach to what that might be. So Steve, take it away.
Yeah, so the main differences between the old world and new world is essentially the physical cabling and the data centers. So no longer do we have to go to any data centers. We don't have to install any kit. We don't have to connect any cables, things like that when we're using cloud. So back in the day, for example, I was working for a company. They had a problem with a link between two data centers. There was a link in the middle. There's an exchange there. And that was provided by a large telecoms company. We had some issues on that, and we essentially had to get an engineer to come out for us. I had to meet him there. So I was there for about midnight, which was the time he was supposed to turn up. He didn't turn up till 3 a.m. He rudimentarily checked the equipment here and got one of his colleagues to check the equipment there and said, it's not our problem. At which point, I basically held him captive until he fixed it. So I escorted him to the exchange where he actually found the fault, and we got that sorted by about 6:30 in the morning. But he was adamant that, that it wasn't his problem. Ultimately, the fault lied on an interface in the exchange. That's the sort of things we used to have to deal with. Thank God, really, we don't have to deal with it anymore, because layer one is the bane of everyone's life, really. When cabling goes wrong, it can cause massive delays.
Yeah, so you may hear us, or we've talked in the other sessions as well, about layer one. We're not going to take you through the OC model, but that is what we are talking about. Layer one is essentially physical, everything from power to physical cables you plug in, copper, fiber, and then of course the actual hardware. So, tell us a little bit more about that. I think again, still focusing on that old world of deployment. What were those things that we had to consider? Maybe some other stories that you had about. You're absolutely right. We had to go into the data center. That's been abstracted away from us now. What were other things that we maybe need to consider in doing that?
Yeah, we used to have to obviously take the kit with us. It was all done out of hours, so the data center may be close, it may be miles away, so you have to take travel into account all the time. It was wasted traveling, although there was bonus for overtime. But yeah, we had to get to the data center, start the work out of hours. We'd end up putting our hands in cabinets, getting cut by cables, cable ties, and try to mount something in a rack. You get your fingers in the old rack bolts, and there'd be blood everywhere. So yeah, those are the sorts of things you need to do. Drive there, and if you got it wrong, and you essentially have to go back. You can't just no, that's it. So everything had to be done. You had a data center manager saying make sure all the cables are labeled correctly and things like that. Easier said than done at 5 a.m. when you've been up for 24 hours. So they're the things we used to have to deal with.
Yeah, I think what this reminds me of as well when we were first doing this was that everything was very physical, very tactile, and we had to be responsible for everything kind of top to bottom. So we did have to go and physically deploy. So everything, of course, was physical. There was nothing in software. Everything was in hardware. And it may be as ridiculous as what you are currently thinking. Someone in their early 20s, i.e. me, who had a range of Fiat Puntos, not something I'm absolutely proud of, but sadly that is my car history, would take the devices to the data center. And that was essentially as good as the couriering got. When you've got a small car, particularly if you want to do multiple things, and these are real life stories, the packaging was huge that came around the boxes, so the packaging had to come off. So I would like to say that you got very good at being particularly careful when you took a roundabout so that the kit did not smash across the side of your car. Sadly, if anyone has a data center with any tech in it that's the better part of 20 years old, it probably has been smashed around in a Fiat Punto or other car. That was very much how it was and how it had to be. We were talking as well about things like the cabling. This isn't just pulling the cabling from the outside in, this is the cabling across the data center. So deployment for us had to be very, very considered. We were talking about carpet tile lifters, having to actually lift the floor to run the cables and go through sort of thought process like that. I think something you touched on is quite interesting as well, which may or may not have been a design consideration. You said we had to get up and we had to drive our cars, and that's absolutely correct. Therefore, the geography was an important thing. So what did that lend itself to? And what did you see from the sort of geographical positioning of these sorts of things?
Yeah, I mean, from the companies I work with, they tended to have their data center located in their head office as one, and then they'd have one in another office close by, or they'd take co-location close by, albeit so engineers could get there quickly, respond to things quickly, and essentially it was usually within a 20-mile radius. It wasn't geographically diverse like we see today, with the big public cloud providers. There was some companies I worked for who did have north and south data centers even as far as Scotland, but it was few and far between. Most were in the vicinity, or at least the local area.
Yeah, I think that's really interesting to give you an idea as well of, I'd love to think that these were design considerations, i.e. we'll keep stuff close to us because of X, Y, and Z. The X, Y, and Z probably was that people who worked for that company or for the technology teams working for that company, be they outsourced or within, needed to get there sooner rather than later for whether they were putting something new in or they were trying to resolve an issue. So things were kept geographically close, which may be a good thing, but really probably doesn't lend itself to being the best approach, or at least a very good approach. For example, I think most people know I come from the east of England, and in Norfolk, it is safe to say that it wasn't awash with high-profile data centers. So those data centers that did exist probably weren't the best of breed. So you're probably then not getting the best out of the considerations for how those data centers are being put together. So that really was quite an issue, I think, as well. Of course, when you're having to drive somewhere, you're having to do something from a hardware perspective. Once you go and once you come back, that's the end of it. So I know at Cable and Wireless, for example, our primary data center at the time was in Swindon. And again, if you're having to drive there from South Norfolk, that is quite a trek. Particularly if you get there, get back and realize that you didn't do something. So I think something else you touched on there is quite interesting is the use of HQ. So this is something that we don't see anymore. This was actually because of reducing costs, so there simply wasn't enough data center space.
I think there is that, and I think as well, because most of their users were in that building at the time, obviously your response time, your applications are going to run better, closer. I think another reason the geographically close was the technology for things like fiber, the SAN replication, things like that had to be within a certain threshold of latency. So you'd have to be within sort of 20, 30 kilometers to enable that to replicate. So I think there's considerations around that as well.
So I think the key message there is that not all that long ago, despite the fact I think we're probably feeling older nowadays, we're only talking 20, 15, in some cases 10, maybe you see this right now today, years ago, this is the sort of consideration you had. Everything was hardware driven, and you had to think about how you're going to position these things, how you're going to use these things, and what effect that might have on a very lovely design that you might have done on paper based on the fundamentals of what your architecture wanted to be. But sadly, that was problematic, which of course leads us to talking about how we would deploy inside of the public cloud and how that really does change everything. So Steve, I'm not even going to try and lead the horse to water here. How has that changed? What sort of things are different? let's look at all the good in there rather than trying to find any problems.
Yeah, I mean, obviously, you no longer need to go to a data center. So they're Amazon, Microsoft data centers, all that cabling, all that layer one stuff's done. They've installed the hardware. There's massive blocks of compute, and you're essentially just using a slice of that compute and network to build your infrastructure. So we don't have to leave our seat anymore. We can work anywhere in the world to deploy virtual machines and network functions within cloud. So if we want to deploy a few VMs here in a subnet there, then we've got a couple more. And let's say we wanted to add some security and we thought we'll put a firewall there. We're going to have an interface into that subnet, that can be achieved in a number of ways. So you're looking at going through the console, deploying it manually, clicking on a few boxes, adding IP addresses, things like that. Once you create your VPC, adding an internet gateway, and you can build that within, maybe an hour manually like that. There's no need to go to a data center, and that's just there. The other way to do this is infrastructure as code. So you've got AWS, we've got CloudFormation, things like that. So you can code all this deployment. I'm sure some of you know that into CloudFormation. You can click a button and it will deploy everything. You can also delete it, redeploy it again, edit that code if something's not working, and again just keep bringing it down, spin it back up till you get the desired deployment you want.
And I think we were talking as well, this is actually a conversation that came up in the week. We've had a lot of conversations this week to try and facilitate the session. It's about an approach. So there's a little bit of design in here, but I think this is deployment. Is when we have worked with bigger companies, maybe they have had multiple staging environments for what ultimately gets into production. But that is a problem. If you think back in the old world, and let's talk about hardware in this instance, you would see a production environment and you may see a staging environment. The staging environment may not be used very often, but it carries exactly the same cost and collection of dust as your production environment on the right. So that's absolutely fantastic if you are a FTSE 100 company or you are particularly risk averse and can find the money. But there are many big companies as well, of course, as all of those that are smaller that simply couldn't afford these approaches. So we see staging environments in cloud. I think that's something we hear a lot. Have you seen more companies utilize staging environments that traditionally, possibly for cost, maybe for other reasons, wouldn't have done?
Yeah, definitely. I think cloud lends itself to be able to run that because it's on demand and you've got the on-demand payment model. You can spin up your staging environment. You can do what you need to do. You can tear it down. You're already paying for it while it's up. So I think from that perspective, even the smaller companies who couldn't afford to have a replica infrastructure can do that now. Whereas the companies I work for mostly didn't have a non-live environment or a staging environment. It's like we'd be able to test our changes on virtual infrastructure. So we'd have to build the network within a virtual lab, test those changes. Obviously, the developers can't test those changes at the same time because that wasn't hosting the virtual infrastructure. So it was all a bit segmented, nothing brought together. I think with cloud now, because of the pay-as-you-go and the way you consume it, that's ultimately led to people doing things in a more, a good practice way.
Yeah, and we talk about good practice a lot. Good practice and best practice aren't the same thing. Best practice infers there's one way to do something. We don't really subscribe to that, particularly nowadays when there's so many different ways that you can skin the proverbial cat. There are good ways in order to get to each of them. Now, of course, that makes it sound very much like cloud is the wonderful answer to everything, and we like to try and be vaguely objective in here, particularly as we're network people. So that all sounds great. I think we have seen some complacency come in with having access to all of these things versus, like I said, when you only get one shot at something, particularly if it's a 200 miles to the left of Norwich, you have to get that correct and make sure you get it correct. Doesn't mean you necessarily are, but there's a different approach to that. So we talked about in the design phase about extrapolating network. Can we extrapolate the network function out of here? Because I know we're going to come to some troubleshooting bits that show us that there are problems in here. What we know this has done is reduce time and save money. We can, it's quick, and at the end of the day, we can tear it straight down, so there's no cost. That's great. Have we seen any issues? We talk about ASIC. One of the things that came up during the week was about ASIC and hardware, a deployment consideration around how that works.
Yeah.
Let's just, for those who don't understand ASIC, talk a little bit about if we had those devices outside of there and how that affects it differently. So why we might choose it.
So essentially, an ASIC is a hardware chip that has usually a single function, and it excels at that function. So it's coded to. So let's take IPsec, for example. On your next generation firewalls, or most firewalls, they'll have an ASIC just there to do IPsec, nothing else. They'll have one for URL filtering and other security mechanisms, and that is hardware coded, so it is super fast, and it'll just get that to work. The difference what we've got in cloud is this is all on generic compute. So you're looking at x86 architectures, you've got some ARM architectures now, maybe containers, there's a few new chips, and we may even get to the point in the future where these can run as well as they do today on ASICs. But fundamentally, this won't have the throughput what you can get out of cloud. So because of those limitations, CPU and the cycles, and because they're not optimized for those functions, if you needed high bandwidth, let's go for broke here. Say you needed 50 gigabits per second through the firewall here, you're never going to get that, not at the minute. So the network adapters within the cloud maybe able to do it and things, but you're always going to come with a limitation on that chipset even. So if you were to deploy out of cloud here, we're putting another firewall here, because hardware that has the ASICs and things like that, we can get a lot more bandwidth through the ASIC driven hardware. But yeah, there are limitations, and under the hood as well. These aren't really published by the cloud providers, but there are limitations on packets per second to things like EC2 and VMs, which aren't published. So if you might hit your packet per second limit before you hit your bandwidth limit and things like that. So it's not really, well, you can't see the full picture. It's a case of you'll have to do some benchmark testing and things like that before you really understand the throughput. I've learned through looking at the data sheets, that certain amount of CPUs will get you this bandwidth. I've never got anywhere near those data sheets at all. Sometimes in the region, something will say it can do 10 gig. I've managed to get 5 gig through it. So we're looking at orders of magnitude lower than the publicized statistics.
And I think that sort of sounds like, I said there'd be some overlap. Sounds like that's a design consideration. It is a design consideration, and I think that's probably a level or 2 or 3 or 4 lower than what we talked about in our previous design session. These are the sort of things that do require a great deal of consideration. I do also think that this steps into the world of deployment, because deployment is also about the decision you're making. We talked about time and money, but also we need to think about functionality, we need to think about performance, we need to think about why we might be seeing issues, which kind of takes us neatly into talking about troubleshooting. So we want to talk about those things that we have seen that need resolving, those things that we have resolved. Again, we talked to people during the week. So we've got some great feedback on the sorts of things you'd like to see us talk about, from people we've known from Network Past and people we've met recently via the working world. So I've got to start with an interesting one for us. It's very network specific. And it is what we stepped into. So if you remember, we talked about what the public cloud is attempting to do, has done, is remove layer 1 and layer 2 away from you, the engineer, the person using that cloud. Layer 1, we just said, that's great. That means we no longer have to drive to Swindon and lift carpet tiles up. Brilliant. But layer 2 could cause some issues. So when we first moved into the cloud, from a routing perspective, we were talking about, okay, so how do we use OSPF? So as an open standard routing protocol inside of the cloud, our natural assumption was we'd be able to take everything that we'd always known in Network Past, everything we've been taught, and simply move that and lift that and shift that into the cloud. Sadly, spoiler alert, that wasn't actually what happened. So this was very much what we had to do at Cloud Gateway. So Steve, take us away with OSPF. We thought we could just go and smash that into cloud, and we could.
Yeah, so on our first foray into cloud, when we were experimenting, Cloud Gateway, how we were going to build the products and things like that, we were doing some testing, and we had a use case where we had essentially a couple of routers in the cloud. They were MVAs, can't remember which ones they were. They may have been Cisco, they may have been something else. We had some sites connected up here. And we essentially connected that to some other sites down there. We split this at the time because we were only using tiny boxes, and we couldn't get the throughput we needed to do the testing on either box. So being a network person, you think, oh, we can just go into cloud then. easy with the design phase. We'll just run OSPF between those two routers. So these are on a subnet there. They both got an interface on, and that'll be it. Should be easy, right? How wrong we were. We configured OSPF and then spent a good while looking at why it wasn't working. So we went through all the troubleshooting, what you'd expect a network engineer to do. Obviously, no layer one. What had happened is, because OSPF uses multicast, and you've got a route table underlying here in AWS or Azure, that multicast was essentially being dropped as soon as it comes out of the router. So what usually happens on a layer 2 network is it'll broadcast. It'll essentially send a multicast packet to a predetermined address that OSPF has, and that router will get that packet and go, you're looking to form an adjacency. Then it'll go through the protocol and it'll essentially form a neighborship there. So OSPF, I've missed that one, but it stands for OTIS. Open Shortest Path First, and it's an open standard routing protocol. So then we went back to the drawing board, having figured out that multicast won't work in the cloud. We're going to have to give that one a miss. So we did come up with a solution. It wasn't really that elegant, and it brings with it a lot more complexity, but we had to encapsulate the packet. So we essentially built a tunnel between these two routers. So tunneling technology or encapsulation technology essentially wraps the inner payload of the inner packet inside another packet. So the one we used was GRE, generic routing encapsulation. And that allowed us to create the OSPF neighborship. So that was all up. What we then looked at was what a tunneling protocol does is essentially lowers that MTU. So your maximum transmission unit, the size of a packet that can get through that tunnel is drastically reduced, which has effects throughout the whole network. They're notoriously difficult to troubleshoot. But that was dropping our MTU 1420. Typically in the data center in cloud, your MTU on network device is going to be 1500 as standard. In the cloud, you can run that up to sort of 9000 with jumbo frames. Essentially, what happens is, if you don't ensure that when your traffic is egressing your network in any of these sites, the MTU is squeezed down to 1420, those packets are just going to get dropped. And this tunnel's just going to go, it's too big for the tunnel, drop it. That manifests in essentially, if you were loading a web page, a good combat indicator is you load a web page, it comes up all a little bit malformed, it can't load images and things like that. That'll essentially tell you you've got an MTU issue. Another one is bandwidth. So if you're doing a speed test between sites, you'll essentially get megs instead of hundreds of megs because those packets are being fragmented somewhere. They're just not reaching it, or they're being dropped. So that was OSPF. We decided not to use OSPF because of the complications there.
So I'm going to just hold you there. MTU.
Yeah.
Let's just. So what is MTU? For those people who don't know what MTU is, and just give us 30 seconds on MTU, because as a network nerd, it is absolutely one of those ones that I mean, how many times we've looked at MTU issues? So what is it, and what, like when you talked about then, like packet fragmentation, what does that mean?
Okay, so yeah, MTU, as I said, is maximum transmission unit. That essentially means the packet of a payload plus the encapsulation and any headers needs to be under 1500 in a normal Ethernet space, and once you're going in tunnel, under 1420. So you have to
that's bytes.
That's bytes. Yeah, you have to artificially change that. You can play about with what's called TCP MSS, which is a maximum segment size. And there's calculators online you can use for that, or you can go back. If you can remember your networking days, you can actually calculate that. But it's a little bit of trial and error. And yeah, you essentially have to get that MTU squeezed down to the lowest on the network. So you could be going through 10, 15 routers. If your MTU isn't hitting 1420 at this point, that packet is not going to work. And that MTU is calculated between the two. If you've got two servers or two sites, they will, when they send their SYN, which is part of the TCP three-way handshake, they will send a SYN with the maximum segment size. So they will say, we want to use this. The other end will come back and say, SYNAC, can we use this? And the lowest one usually goes, and then they start transmitting. So yeah. Sorry, what was the other question?
No, I think that was the question. It was a little bit about MTU and how, like you said, how it kind of fragments. And essentially, if you're sending smaller, you're sending more packets but of a smaller size.
Yeah, well, your network's not optimized at that point. You're essentially losing bandwidth. So if you've gone from 1500 to 1420, that's a reduction in bandwidth. You're going to get less bandwidth through there. So yeah, it's a non-optimal way really to use tunneling technology. I'd steer clear where you can.
Yeah, it's definitely one of those. Again, I kind of talk with a wry smile, because I know that as a network person, coming up against MTU issues is kind of like you say, the one of the many banes of our network life, but also just seemingly causes more problems than at times it appears to resolve. That's probably not true, of course, but it is something that has come up a lot. So have in fact, I want to just take that moment to go to a question that we had. So unashamedly, we took some questions during the week, so that we asked people what was some of the things you'd like us to talk about, rather than always just assume it's going to come through like a chat channel. So I'm going to move to what our first question was, quite an interesting one, which was, we've connected our WAN to AWS via Direct Connect. Why can we not see the WAN routes on the VPCs? So if you drew that, what would that, I guess, what would that look like? And I guess what the question is I'm just thinking about this from which direction it is inside of AWS.
Yeah, I'm
not receiving the routes from the WAN. Why am I not seeing those?
Yeah, so we see this quite a lot, and this is just, the deploying networking cloud. There's a few things and a few tick buttons you have to tick to make that happen. So you've got your direct connect here, IDX. You've got AWS up here. And your WAN providers put this in. Everything looks good. Everything's routed accordingly. You're seeing the AWS routes, but in here you can't see the WAN routes, which essentially means you actually have to point static routes down there, or you can't get your end-to-end communication. Within your VPC menu, under that VPC and that connection, there's a little button which it used to be sufficiently hidden. They probably made it bigger now, but on one of the tabs, essentially there's a little tick box that just says propagate routes. And that then allows those routes to flow into here. And again, if you're connecting multiple, that means you can pick where you want to propagate your WAN routes to. So you may have another AWS here, and you don't want to propagate the routes there, but you've got it connected, or you only want to use static routes. So that just means it'll take all these into here. Again, limitations on deployment, 100 routes into AWS. If you exceed 100 routes, your communication will fail. This direct connect will go hard down until you reduce that limit to sub 100 routes. You'll essentially suffer an outage.
So is there a way, if you're on an enterprise WAN, and there are a million reasons that we're not going to go into for why you can't just have a dirty great summary route, you are going to have more than 100 routes you have to propagate into AWS. Is there any way to get around that?
With AWS, there is. You'd have to, again, run an overlay, which is what we were saying there, put a router in there, and essentially use some sort of tunneling mechanism or IPsec to essentially shift the routes to here. But then what you have is you have to use static routes then to point them at that EC2 instance. Your other option is to bin your AWS deployment and go for Azure. They will accept 4,000 routes, and on the high-end SKU, you can get 10,000 routes. So most WANs are probably sub 10,000 routes, but probably most are sub 4,000 routes. But some are going to go against that. Some are going to be humongous if they've not been designed properly or planned for properly or just grown organically. You could well have more than that. But that is a major issue we have with AWS. And we actually, on our service, we control those routes for external networks like the HSDN and the PSN. We summarize those and publish them, and we've got monitoring alerting on those that says actually you're at 52 routes now and things like that. So yeah, conscious of that all the time. That can be one in deployment where you've not read the FAQ or things like that, and you've suddenly 1,200 routes up there, and AWS has gone, and it'll just go BGP won't establish, and it'll just keep going open, confirm, close. And yeah, again, unless you've read the documentation, it's quite difficult to find that.
And so you talked there, that's interesting. So there is a very obvious difference between AWS and Microsoft, and I'm keen not to get into a theological argument as to what is the best cloud, because there'll be many reasons for why I would answer that. From a networking perspective, and let's not, again, try and make it as a competition, have you found that one of the two feels like there is just is better suited for networking?
Well, I'd say
It's quite balanced.
so. I would always shy away, and this is through previous experience, in my opinion, of putting network devices in the cloud. It's not built for that. You know, if they're not optimized, you have to. You're essentially increasing your technical debt within the cloud. You have to make, you know, things like static routing and things. It gets rid of the dynamic aspects of cloud, and you're making changes and more things. So if it can be avoided, I wouldn't personally deploy a network device in the cloud. From my perspective, you know, that they're the only reasons AWS and Azure I'd go for Azure if I had a massive one and I couldn't summarize those routes. I'd definitely be leaning towards Azure. With AWS, the only other option would be to summarize it, do that work, look at everything and summarize it, or just advertise the sites that need to get to AWS. Not all your sites might need to, so you might filter routes here so they don't get up there. So yeah, but there's not one better than the other. It's just the limitation on AWS is a lot greater than it is with the Azure.
Cool. Another question that we have brought to the table. I've got a 100 megabit per second link to Azure from my HQ. We're nowhere near our bandwidth limit, but the connection is slow. What could that be? So there's also, we talked about banes of network people's lives, just because I'm going to get the opportunity to say is something working but slow. That is the single worst thing you can hear as a networking person. It's not working is great because we can attempt to fix it. It working, but it's a bit slow, nightmare. So what would your, well, apart from wanting to go home or book holiday, which would have been mine, what's your thought process? How would you step through that troubleshooting process, and what do you think you might find in the end?
Well, I mean, it's going to be something to do with MTU, isn't it? So if you've done your checks, obviously you will have sort of layer one here in your HQ. You'll have plugged that straight in. That'll all be connected. You should be running a routing protocol over the top, so that should have adjacencies that should show you that your layer 2 and layer 3 are working. If it's still slow, you've definitely got an MTU issue. So like I said before, MTU issues manifest themselves in not showing data correctly, or malformed data, or not loading images, and potentially, you know, you're trying to say you're migrating data from here to here, you're going to have an MTU issue somewhere. Where that is, that's the horrible part. So, you know, it may look fine here on the router that's connected to Azure. You could have people connected over here. There could be 3 or 4 routers in the way, and your MTU issues, you know, going to be somewhere else. It could be within your LAN, and that's the thing. You have to literally go through the whole network path, looking at MTU, looking at MSS sizes, comparing where it has. You know, someone may have put a tunnel for whatever reason. They may have just said, "Oh, we've got 2." Well, the HQ is split into two buildings on the campus. Someone's gone, we're actually going to encrypt this, we're IPsec, just so someone can't tap the cable or things like that underground. They've then removed, they've then reduced the MTU because of that tunneling. So it could be there. So that's the thing with MTU. It is a network engineer's worst nightmare when those 3 letters are said. But yeah, that's the problem. It's going to be MTU on that. It's not. It's unlikely to be Azure. You know, everything with Azure that they do, we've used the service for ages now. We've got customers using the service. That, you know, you don't get typos with Azure. Some service providers in the old world, instead of putting 100 megs on your circuit because they'd be policing or shaping that traffic, they may forget to add a couple of zeros on the shaper. You may end up with 10 meg, easily rectified with a phone call to them and a bandwidth test. But with Azure, everything's automated, done by APIs and things like that. So the computer isn't going to forget those zeros. So it's unlikely to be that.
Yeah, it's an interesting one. Again, that's the sort of things that, you know, it's taking us away from a business perspective. All of a sudden, it's the sort of thing that my son would really struggle with, because we now have gig fiber out in Norfolk, and if he sees a website going chonk 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 as things are coming through, he's entirely confused, because to him it's just a really, really fast internet connection with a really not fast thing happening. And as Steve says, I play dumb and tell him I had a very different job and never ever want to look at MTU again. I'm perfectly honest. That's his issue, not mine. So I think we'll take this one as a final question before we wrap this up. We have just acquired a business. They use AWS, we use Azure. We've connected them together, but it's not communicating. How do we figure this out? That's obviously quite broad. So, I mean, that's what this is about. Like, where would we start? What would our first thoughts be? And what are some of the things that, you know, we may want to go towards? And whilst Steve's just drawing some of that out, that is surprisingly common. I'm not saying that businesses, of course, are necessarily acquiring or merging all the time, but actually, you more so than you may think. Certainly from merging, not so much maybe acquiring might be kind of bigger, but when you've got that approach where one has very much put its eggs in, the AWS basket and one in the Azure basket, then of course the two need to speak. So
yeah, so I've gone on the assumption that it's purely in cloud. They're going to use a VPN to connect these. So where I'd be looking at is is the VPN up, so you can look at the dashboards. That'll show if the VPN's up. Like I said in the design, you should really be using PGP. It's there for use. I would take advantage of it where possible. And again, make sure you've got the box checked for propagate routes in AWS. Azure will do that automatically. So you look at that, you look at the routing is correct. Yeah. I mean, what you could have, and we've seen this many times with mergers and acquisitions, is, these guys have used the same IP addressing as these guys because they never thought they were ever going to, come together as one single entity. So they've used 10.4, they've used 10.4. And again, that means the traffic's just going to stay within here. You're never going to get over there. Again, on the route tables, if you've not propagated it and you don't want to use BGP, you'd have to add static routes to your VPN gateways again to make that happen. So there's a few things there. I'd start by looking at the VPN. I'd then move on to the route tables. Are we using BGP or not? Are the routes propagated? You should be able to see those in here and in here within the VPC or the VNet routing table.
And presumably, and I guess I'm leading us to one of our other nasties, is if there is IP address overlap, I think I know where the answer goes. There's two ways of resolving that.
Yeah, cancel the merger.
3 ways of resolving that.
Yeah, well, that's the beauty of cloud, right? Although there may be more considerations if they've got other connectivity, but
sure,
they could, depending how they built that, they could just, another cloud formation template, different IP addressing, press the button, and it all comes back up. Obviously, it's not going to be that easy in reality. Yeah. They are going to have other connections to other third parties and things like that. So that's another one. The other way to do it is to use or tag on another subnet in both directions. You can use things like NAT gateway. Not ideal. Or you can put something I told you don't do, or you can put a network device in to do that static NAT to allow them to talk to each other temporarily, which will never get changed, by the way. All these tactical fixes in networks just get left there once it starts working. So yeah, that's another thing to do. So that gateway is, or you can put some devices in there again, but you're then building up more complexity, technical debt, and at some point you're going to pay a massive interest payment on that debt.
Yeah, I think so. Steve went straight for the two that I was thinking of. 1, readdress it. 2, NAT it. No one. Well, I say no one ever readdresses. You make a good point. It's about what is consuming outside. I just sort of had like this kind of PTSD style flashback of something we did in a previous working life, where it's not uncommon that the two parties that come together, particularly if they're quite big, just refuse because someone has a huge amount of work to do. So when it's readdressing, it ain't happening. It's going to be NAT. Whereas actually, it's probably something that's not a bad thing about the cloud approach, because it is software driven, and we talked about automation and scripting. It is at least much more simple to do with the other considerations.
Yeah, and I think because DNS is so easy to do in the cloud these days, so everyone should be using DNS. In the old days, we had servers hard coded to talk to IP addresses of other servers. Yeah, you'd have to take that into account. I think a lot more people, because of the ease of use with DNS and Azure and Route 53 and things like that, it's so easy to change those IP addresses. It shouldn't be a massive issue. Like you say, back in the old world in data centers, that was never getting readdressed. That was someone's, if they were going to do it, that's like a 3-year project for some environments. Yeah. And there's so much disruption just from readdressing things. The business was never going to sign that off.
Yeah. I think just closing this out now, DNS is an interesting one. One that if we'd had more time, we'd probably talked about DNS. That comes up a lot, which, because it's being used more and being used in a sort of the correct way, I'd like to think. But if you use something more, chances are you're going to have more things that break and they're not working. So I think that's probably something we'll talk about outside of these sessions. I think one of the things that is probably the kind of overwhelming takeaway for me, and I don't want to feel like we at Cloud Gateway are pushing an agenda on this, but it's very much how we feel, is you'll hear Steve saying that the answer to everything in here from a troubleshooting perspective was that you can do it. There are ways in which you can build on top of cloud to affect network function and functionality that you want or need to then support the other pieces both inside and outside of cloud. Is that optimal? I think we would say in most cases the answer is no. If you're putting something in that is small, it's to create a sort of a sub function or just to get over a small hop, maybe that's not a problem. But the reality is, if you're doing it any bigger than that, it's going to be a massive problem. And you know, Steve said another sort of classic network thing there is temporary and tactical fixes in networking are never temporary and tactical. They are always strategic. They always end up sprawling. They always end up becoming a complex nightmare and mess. And again, we talked about through all three of these sessions that Amazon, Microsoft, public cloud providers built a fantastic function and set of tools and tried to abstract network pieces away because it was much more simplistic for what they were trying to achieve originally. The complexity has arisen in the way that people have used the tools that they've been provided. And we believe that that's probably just going to get harder and harder and harder. And so, yes, there are ways in which you can get around it, but be very, very careful, because if you do that, particularly if you don't really know what you're doing, you're introducing problems. As that complexity sprawls, bigger problems, it is not a bad thing to extrapolate and abstract functionality from cloud to be able to support cloud. So these things are all very much, work kind of in a symbiotic harmony, or certainly they can. Now, I know that is a potentially divisive view, but it's something that, of course, we're very keen on having the discussion on because, like I say, it's not an agenda to push, but it's something we feel strongly about and we think is going to get only more problematic over time. So now is probably a good time just to wrap up and finish these, like I say, 3 sessions. We made no secret of the fact that we wanted to use this as an opportunity to create a community. Much though I joke, we haven't had absolutely thousands of people join this, but this is what we will build upon and what we want to continue doing. We want to finalize and finish out some smaller videos to be able to give you some examples of other troubleshooting pieces. We talked about DNS. We want to give you some opinions on what we believe, again, what we just talked about with networking in cloud. But what we want to do is grow this community to continue this discussion. Being able to get people's opinions who are both technical and non-technical on networking and cloud, and just the ever-growing and evolving technology landscape, both with the things we know and the things we don't. Being able to share those thoughts and opinions means that we hope that we and you will continue to benefit, whether you apply that directly to your business, somewhere you're working now, or somewhere you may work in the future. So thank you for being part of this. We look forward to getting your feedback from this, speaking to you in the future, and continuing what we've started. Thanks very much.
Cheers. Thanks all.